All right, as a lead engineer, I want to walk you through a hidden risk that can totally derail our projects. And we're going to use a really simple analogy to make sense of a problem that I promise you, you've definitely run into before.
You know the feeling, right? We've all been there. You hire a plumber to fix a leaky shower, and the next thing you know, the sink is acting up. So today, we're going to dig into why that happens, and not just in our houses, but deep inside our complex software systems, and most importantly, what it means for our timelines. And look, this is way more than just some quirky household glitch. It's actually a perfect real-world lesson in how interconnected systems really work. And understanding this, it's absolutely fundamental if we want to build technology that you can actually count on. Okay, let's get into it. We'll start with the simple physics of plumbing. Seriously, if you can get your head around this, the software side of things is going to click into place perfectly. So here's the key thing to remember. What looks like a bunch of separate parts, well, they often share a hidden foundation. You know, your shower and your sink, they've got their own faucets, right? But they all connect back to the same main water lines. Think of them like two different branches on the very same tree, totally connected by the shared root system you can't even see. So, what happens when a plumber starts working on that one shower pipe? Well, it sets off these invisible ripple effects. Suddenly, the water pressure across the entire system changes. You might get air pockets in the lines. And here's the kicker. Tiny little bits of rust and debris get knocked loose, and they start traveling through the pipes. And this is where it all comes together. That little piece of debris, right, the one knocked loose from the shower repair, it travels all the way down the line and clogs up the cold water valve in the sink. So now, the sink is broken, even though nobody laid a finger on it. The system just, well, it rebalanced itself in a totally unexpected and pretty frustrating way. Okay, so now let's make the jump. Let's go from pipes to code. Because this exact same idea, these invisible connections, it's what governs all of our enterprise software.
And here's the technical term for it: system coupling. All it means is that our apps and our services are linked together in ways that, well, you just can't see on the surface. Just like the shower and sink share that water main, our software components are all sharing things like databases, APIs, and data flows. And you know what? The analogy is pretty much perfect. That change in water pressure, that's like a shift in our software's overall balance, its equilibrium. And those little bits of debris floating through the pipes, in the software world, that's like a tiny, unexpected change in a data format. It just moves downstream until, bam, it breaks a critical report or a dashboard that someone relies on. So let's talk about how this stuff plays out in our own tech, like every single day. This isn't just a theory. This is the real world of what it actually takes to keep everything up and running. Okay, so check this out. What's so wild about these examples is that in every single case, the first change, it was totally correct. It was a good change, something that needed to be done. The real problem was a hidden dependency. You had another team somewhere else that was quietly reading from the same pipe, so to speak. So when that one component changed, the whole system tried to rebalance itself, and things just broke. And you know where this gets even crazier? With our AI systems. I mean, these are basically just really complex pipelines of data and models, so they are super sensitive to this stuff. You make a tiny little tweak to a prompt, and it can just slightly change the output format, and boom, an automation breaks. Or you get a new version of a model, and it subtly shifts how it classifies things, and a whole downstream process just falls over. The network moves, and everything connected to it has to move with it. So the big question is, right, how do we protect ourselves? How do we protect our systems and our project timelines from all these invisible ripple effects? Well, the answer really comes down to adopting an engineering mindset. The way we manage this risk is with something called regression testing. And this is basically our version of the plumber going back and flushing every single line, opening every faucet, checking every valve after they've done a repair. We are intentionally testing the entire system, not just the one little piece we changed, because we are actively hunting for those weird, unintended side effects. And this right here, this is a fundamental truth that every experienced engineer learns. And believe me, we usually learn it the hard way. We have to test beyond the immediate change, because we know for a fact that the real system is always, always bigger and more connected than the map any one of us has in our head. And that brings us to what's probably the most important point for all of us, especially as stakeholders. This isn't just some techie detail. This is directly tied to our ability to deliver on our promises and, keep things stable for our users. So here's the takeaway. When the engineering team says they need to budget time for this regression testing, it's not a delay, it's not a roadblock.
Think of it as essential insurance for our delivery dates. It's the work we do up front to prevent a small, simple change today from turning into a massive, project-killing disaster next week. So this is the question we really have to ask ourselves in every single project plan. Are we actually building in the time to check the whole system and not just the little part we changed? Are we respecting the true complexity of what we've built? Because at the end of the day, our systems remember every single connection, especially the ones we've forgotten about. And dealing with that reality, well, that's how we build products that people can truly rely on.